All right. Hello, everybody, and welcome back to the stream. I hope you guys are doing well today. So, what we are doing here on this stream is we are developing a game engine live here in stream, completely from scratch using C and Vulkan as our initial rendering backend. And the whole thing is completely open source. It is available at kohiengine.com. If you check that out, you can get access to the source links and everything like that. And yeah, it's 100% free, open source, always will be, right? With that said, I do have some supporters I'd like to thank. And they are the supporters over on Patreon and YouTube memberships. Starting with our partners, who are the highest tier of subscription on those places, who are Arslia, Gobollies Inc., and Patrick Kuhlman. I'd also like to thank all the other supporters listed here. They are the other tiers of support over on Patreon and YouTube memberships, as well as Twitch subs. So thank you guys very much for your support. I greatly appreciate it. All the funds and whatnot from that generally get rolled back into this channel in the form of better equipment, software licenses, things like that, right? So the support definitely does help grow the channel, right? Okay, I'd also like to individually thank, as well, I should say, all of you who are the viewers of the channel. Without you guys, obviously, none of this would be here, right? So thank you guys very much for your support. It is greatly appreciated. So, what we are doing is we are continuing on our UI system, our standard UI system. Hey, Weird Trash Can, I'm doing good. How about you? Welcome. We are continuing on our standard UI today, right? So, I'm going to go ahead and just kind of run this real quick just to get a quick refresher as to where we left off. So what we're looking at here is a panel that we are rendering onto the screen. And right now this panel is basically a subsection of this texture that we've created, right? And obviously this texture is going to grow. We're going to have all kinds of extra things added to this as we go. These are just kind of some of the things I thought of initially as we sort of start building out these controls, right? So we're going to be adding a lot more to this image, such as like hover states and depressed states and things like that. But for now, this is kind of where we're starting. So what I'm looking to do tonight is I want to get the button implemented, right? And to do that is going to require a few different things. A, we're going to have to obviously code up the button. B, we're going to have to make something called a 9 slice. So we're going to get an introduction to that if you don't know what that is. And then C, we're also going to need to integrate input into this, right? As well as trying to actually figure out where on the screen we've clicked versus where the control is and so forth, right? So all those things we are going to go ahead and try and figure out. Cool. All right, so for reference on this image really quickly, this is the source that I'm going to be using as the button. These other things are basically going to be, I'm thinking Windows. We might wind up doing this a little bit differently. I'm not sure, how the thickness of these borders is going to work versus this. We may wind up having to tweak that a little bit. But that's basically what we're looking at, right? So we're going to use this section right here. So the first part of this is actually creating a 9 slice. And actually, since I have this image up here, I can actually use this to demonstrate what I mean. So generally speaking, when we're talking about an interface, any kind of user interface, right? We have a lot of things that can be different shapes and different sizes, things like that. And we need a way to be able to dynamically scale those things without them looking all out of whack, right? So if we were to take this this panel here, and we were to stretch it out, the pixelation would be all strange on it, right? And obviously linear interpolation would help with that, but that's ideally not really what we want, right? And so we need a way to be able to sort of squash and stretch shapes to be able to get sort of a uniform look no matter what the scale, right? And that's where something called a 9 slice comes in. And so a 9 slice is where you basically take an image or a section of an image, right? And you slice it up into 9 pieces, and you build the components out of those 9 pieces. So what do I mean by this nine slice thing? So I'm going to use a super obvious color here. We're not going to save this, right? We're just gonna draw here for the sake of illustration. And so what we're going to do is basically we're going to chop up this button, for example, here and here, right? So that's 3 slices. You have 1 slice here, 1 slice here, and 1 slice here. Now, if you're only going to scale this horizontally, you could stop there, right? But we need to be able to scale it in both directions, right? And so we are actually going to chop this up this way as well. So here and right about there, right? And so this is where you wind up with that 9 slice. And the way that it works is you essentially take this box right here and use it to render the upper left corner, and that never changes size, right? So no matter how you scale this box, this corner, or in fact any of the corners, never change size, right? These always remain, a consistent size, right? And I'm freehanding this drawing, so it's not quite so accurate, right? But I think you guys get the point, right? So these 4 corners here never change their shape or size. The ones that do are this side, right? This side, and this side, right? And again, I'm freehanding this, so I'm not so accurate, right? And then also, this guy changes size, right? So no matter how you scale this button, right, or the size of it, you're always going to essentially have a piece that looks just like this, right? And there's 2 ways that you can actually handle this sort of resizing boxes here, right? You can either stretch the contents of those, right? Which in this case would be fine because it's just straight up regular pixels, right? Or if you had some sort of texture in there, like a marble texture or something like that, that you actually needed to define in there and it would look really bad stretched, you could actually tile it, right? And so there's a couple ways of handling that. We'll probably experiment with each. We'll probably write support for both, I'm thinking. That way, no matter what kind of asset you're using, you could sort of have support for either one of those things, right? And so the 9 slice is basically going to be utilized a lot, right? So it's utilized for buttons for one thing. It's utilized for a lot of these other controls like windows. Technically, the panel could use it. If you had a textured panel, you could use it there. You could use it for like the background of a scroll container, like what you see here, right? You could use a 9 slice for that. Or you could technically use a 3 slice for that if you wanted to, right? So the 3 slice is basically the same concept. It's just you slice it in 3 instead of 9, right? I don't know if we'll implement a 3 slice. Maybe we will. Just for the sake of completeness, and then have maybe an orientation or something like that. And so generally speaking, what the 9 slice gives you is the ability to say, okay, this is the dimensions of my corners, right? My corner pieces. Here is where the whole shape is within the image. Make a 9 slice out of this, right? And that's all the data that we should actually have to put in. So we shouldn't have to put in individual pixel points for each one of these things, right? That would be super tedious. Maybe for testing it, we would do that. But generally speaking, you would not want to do that, right? We would basically want to call a function that's got a few parameters, and then it would auto-calculate all that stuff. It would generate the geometry for you, it would generate the texture coordinates for you, based off of those parameters that we passed in. So that is kind of what we're looking at building tonight. All right. Luthcoder, first time chat, welcome to the stream. Mind if I design some UI assets for you just for fun? I would say feel free, but I would say that we may not wind up using them right away because this implementation is likely going to change a lot. And the controls and stuff that we're going to use are going to change a lot, right? So we may not be able to use them right away. So I wouldn't spend too much time on it yet. But what we can do is once the UI system is further along, we can use like user created UI assets in order to test the system out to see how it works with different assets, right? That might be something that is definitely worth doing. So if you do it, then yeah, I might not be able to use it right away, but at some point I would be able to use that for testing purposes, but we're not quite there yet, if that makes sense. Perzimkov, thank you so much for the follow. I appreciate that. Welcome. All right, so let's go ahead and, you know what, let me close all the other buffers except for, let's see, we need UiPass and we need standard UI system C. And let's see, I think we actually put all of this stuff within this file, which we might actually be getting ready to actually split that out, right? So we have our panel here, updates. We don't have an unload for that. We probably need to address that at some point. So I think we can actually reuse a lot of the logic from the panel for our button, and then just sort of build on top of that. So the only difference obviously being is that geometry will be much different. So there is that. Let's see, generate UVs. Did we actually? Yeah, we did come up with a helper method for this. That's good. And so actually, by the way, what we're going to be doing is to generate the 9 slice, we're basically going to be generating 9 of these quads as well. So we'll be able to sort of use that to get us where we need to be. Let's go to SUI system.h. And for this one, we have our SUI control here. We do actually need a 9 slice structure. I'm not sure if that should be exposed or not. I'm thinking it probably should, so that user controls can be a thing. So let's go ahead and do that. So we're going to type def, new structure, and we're going to call this SUI 9 slice. Right? And let's see. We are basically going to have, let's see, do we want to have it hold the geometries? I think that makes sense to have it hold the geometries. So let's go with struct. Actually, do we have? We do have resource types. Okay, so we don't need the struct. So let's go with geometry. We're going to have an array of pointers. And we'll call this quads. Right, so we'll generate those quads. And then we're going to need some other properties. So we'll need to know, we'll need to cache a few things, right? So we're going to say U32. We probably don't need a U32 actually. Let's go with an F32 actually. Let's go with a float. And we're going to say corner width and F32 corner height. Right? And that's going to be the physical size of the corners on screen, right? Not necessarily the section of the image that we're sampling, but how big are the actual corners going to be on screen as we move that thing around, right? Because that size should never change. And then we'll have a U16 corner TX width and a U16 corner TX height. right? And these will be the sampled width height, right? Versus actual width height. I'm not sure if I want to go with floats on this or not, but I'm thinking we should probably support subpixel. That's actually an important distinction. You know what? I'm going to back out of that, actually. I am going to go with a U32. Actually, I can go with a U16 on this. We're not going to have something that huge. So the decision there is we could use floats for that, right? To determine overall size. But when it comes to interaction and how things look on the screen, perfectly vertical and perfectly horizontal lines tend to look really poor at a subpixel position, right? They look kind of fuzzy and they just don't look good. They're not nice and crisp. And so I think we should probably round those off to integers and use integers. That'll also greatly simplify the math behind mouse interaction, right? So I think that's what we're going to roll with there. So we've got that. We're going to say this is actual corner width height, right? Sampled corner width height. And then we'll say U16 width and U16 height. And this is going to be overall width height of control, or I should say of 9-slice, right? And we'll do some verification to figure out what the minimums should be, right? So to use this as an example, if we, in fact, you know what? I'm actually going to modify this image a little bit because this is actually overkill for what we need, right? So our 9-slice, right? If we have, for our purposes, right? Anything that is in this center area, this way or this way, if we're not tiling it, is a waste, right? We really only need 1 pixel of data here. Arguably, you could say 2, just to make it nice and even, right? But we really don't need, all of this, right? That's just a waste because we're just going to be stretching it out anyway. So I'm going to resize this a little bit. So let's see. Let's take this whole section here and delete it, and take this section here and delete it. And then we can take this and move it up. Take this and move it over. Right, so theoretically, this is all we need for our 9-slice, right? I'm thinking. Because our literal center section here, right, is just 1 pixel. Merlin, hello. First time chat, welcome. This is sick. I've been trying to start getting into game dev, coming from standard software background. It's intimidating, but it's been fun so far. Awesome. Well, welcome. It is a lot of fun. It's a lot of work, but there's so many things to learn and do that you'll never be bored, right? There's so much to do. And so we're kind of delving into the world of UI right now. And this is just rolling a UI system from scratch, right? We could use a pre-made one, but we're rolling almost everything from scratch on here. So this is kind of one way that they can work under the hood, right? Okay. So I'm thinking this is actually going to be sufficient for our 9-slice, right? Because inclusive speaking, right? These are our corners, right? These guys. So our corners are 3 by 3, right? just think of the pink lines as actually overriding where our corner, or overlapping where our corners are, right? And then we have this is another slice. Oops, this is another slice. This is another slice, and this is another slice, right? And so that actually works out to a nice little 9 slice that way. So I think that is what we're going to do. Let me export this. Yep, that should be standard UI Atlas. Cool. Let me just make sure that didn't mess anything up here, because I think that's the only change I made, but should still be good. Okay, cool. All right, Merlin, thank you for the follow. Appreciate that. I'll probably be working on physics, so might not interact a ton, but I'll be listening and soaking in. Awesome. Well, I appreciate you being here. And physics is one of those things that we are going to tackle on here, but it's kind of a broad topic. And if you're implementing it, you know exactly what I mean by that. So, yeah, that's... I'm looking forward to it and not looking forward to it at the same time. Okay. So that is what we're going to use for our 9 slice. So let's see, what else do we need? So we have the overall height of the 9 slice. And then we are also going to need to know in the image the source location, min and max, right? So we'll say U16 sampled min X. U16 sampled min Y. Max X and sampled max Y. I really probably should have like an I vector 2 or something like that that takes these, so I don't have to do that, but I don't have it. Is this OpenGL, Vulkan, or a wrapper API? So it is. Right now we're using Vulkan as our rendering backend for now, but it is one of many actually. So what we actually have here is a plugin architecture for our renderer, right? So right now we have a Vulkan renderer, but we're also going to have a DirectX renderer, probably a Metal renderer to get native support on Mac, because we're technically going through a Molten VK layer to get that on Mac. And then I might do OpenGL, maybe for like backwards compatibility purposes. But yeah, you can basically, the renderer itself is a plugin, so you can just plug in a different renderer if you want to use it. Just for funsies, we might wind up also writing a software renderer if I get really bored, right? But that's, yeah, kind of the idea. Okay. Yeah, and so I should point out also that there are two... I said it's a rendering backend, right? So there's a rendering front end that interacts with the engine. The engine knows about the rendering front end and knows how to interact with it from that perspective. And then the rendering backend is the render API specific plugin, like Vulkan plugin. And the translation is made from the front end to the back end. And then, you know, back and forth. And that's kind of how that works, right? So the rest of the engine knows nothing about what renderer it's actually rendering to. It doesn't care. I miss when every OS and graphics card supports the same API like OpenGL. Yeah, well, I mean, OpenGL technically is still supported, right? But you don't get a lot of the new things with it. You can technically just still write an OpenGL backend and have cross-platform support, but it's deprecated, right? So Vulkan is definitely the way to go. I mean, Vulkan is the new version of that, right? Even on Mac OS, it's mostly supported through Molten VK. To be fair, I'll probably come back in like 10 years when Vulkan, most hardware will have Vulkan support. So I would say, I mean, most current hardware is going to have Vulkan support. I mean, I've got a laptop over there from 2015 and it still supports Vulkan, right? So, yeah. How good is Molten VK? So it is pretty good, but think of it like it's not really emulation. It's more of a translation layer, right? So Molten VK can only be as good as Metal will allow it to be. There are certain extensions and certain functionalities that Vulkan has that Metal doesn't have, and thus aren't supported on that platform. And that's not really it's not really an issue of Molten VK being good or not. It's more an issue of what does Metal support. So I mean, I would say it was pretty good. I was able to actually just put the SDK on this Mac over here, and it runs. It runs pretty good, I would say. I don't have a whole lot of performance issues that aren't my own fault. Let's see. Hey, Nathan, welcome. First time chat, so welcome to the stream. I saw a stream recording where you wanted comp time hashing of strings, and this was one feature of C++ you wanted. Yes. Have you thought about a pre-built script that replaces hash? Yes. So I have thought about like a pre-built script or like a or hacking macros or something like that, but I don't know. It just feels dirty, right? So I don't know. I haven't quite decided how I'm going to handle that just yet. But most of the places where I would be using strings for identification of resources would be really high-level code anyway, like game code. And so technically speaking, if I wanted to write the game code in C++ or use the C++ compiler for that, I could do that without having the engine also be in C++. Yeah, the ancient stuff will struggle with it for now. Zig, zig, zig. Yeah, I haven't had a chance to look at Zig yet. Everything is dirty when you no longer just write machine code. That's true. I mean, machine code can be pretty dirty too, though. It's all dirty. There's always dirty hacks. Lord knows I have some of them in this code base here. Okay. So we have this. I suppose we should probably also... So this is the sampled rectangle of the 9 slice. We should probably also have... I suppose we don't need this separate. We could technically get it from the texture, but we should probably store it anyways for regeneration purposes. And that's going to be atlas width. Width. And atlas height. Right? And so as long as we provide these things at startup, when we initially create the 9 slice, we should be able to resize it and do anything we need to do, and it should be able to recalculate it at any given point. And this looks like a lot of fields, and it is, I guess, but if you think about it and like... I really kind of want something better for this, right? Because we have width, height, width, height, width, height, XY, XY. I could literally cut this property list in half if I had a structure for it. Let me look at... I can't remember if I actually created something around this or not. Plain 3D. Maybe I already have something and I just forgot about it, which is entirely possible. Rec2D, quat. We have ads coming here in a minute or so. So just for you guys that are new to the stream, I'd like to pause the stream for ads so that anybody that does have ads that runs doesn't miss any content, right? So that'll be popping up here in a second. We'll be taking a break here in just a moment. We spend like 4 years trying to make something that doesn't exist yet, and maybe other people will be interested. but it's still the best thing you can do. Yep. 100%. Okay. You know what? I'm going to create a structure here. Type def. And we'll call this a vec2i. And I'm going to go with U16s on this. I think that makes sense, right? And in fact, I should probably do the same thing. The same thing that I did up here. So I'm actually going to grab this guy. Ah, we got ads. Got about 30 seconds left on ads. All right, and we are back. So I went ahead and kind of just did this off camera just to save a little bit of time, right? So we're going to treat this the same way that we treated the other vector types, right? We're just going to basically union it. And the way that we're doing it here is we're just using U16s, right? Well, should we use U16s? We probably ought to make these I16s, right? We should probably make these signed. Let's make them signed, yeah, because that's going to be a problem otherwise. Let's make them signed. You know what? I'm just going to use I32s. Because I just get the feeling I'm going to wind up restructuring this anyways. So let's just use I32s. I don't think we're going to have anything that big using these, but just in case. All right, so the basic idea here is we can access these by different names, right? So we can treat it as X, Y, R, or G. We have U and V or S and T, right? So we have all those different sort of naming conventions that we can utilize with this, or we can access it as an elements array if we want to for loops and things like that, right? So this just works just like the other vector types that we have. But it should allow us to have a little bit more of a concise representation here. So do we do not have math types on here. So let's go ahead and, oh wait, yes we do. It's right there. Okay. So where was that? Here. Okay. So I guess what we'll do is we'll change this to vec2i, right? And we're going to say corner size. and vec2i, and we're gonna have corner texture size. And then vec2i, and we'll just have actual size here. And then let me do this a couple more times, and then go back and do sampled min, sampled max, and atlas size. Right? That's a lot more concise, I think. A lot cleaner. So essentially, those are the parameters that we have to provide, right? Minus the quads, right? We know we're going to have 9 of those. In fact, we don't even need to do that. We can literally say we're going to have 9 of them because it's a 9 slice, right? I think that's all we're going to need. So let's create a KAPI. I guess we'll do a return type void SUI 9 slice create. And I'm trying to think if we need. Yeah, we should be able to determine everything else here from that. So let's go vec2i size. We'll do size first. Then we'll do vec2i atlas size. Then we'll do vec2i. Let's call this atlas min and vec2i atlas max. Let me get rid of this for a minute. Oh, it closed the wrong one. Really? Why has it done that? This one. So we have atlas min, atlas max, size, atlas size. I guess we'll do vec2i corner size, vec2i corner sample size. Let's call this pixel size, actually. Which actually we might want to do that across the board, right? That makes it a little more obvious what it is. This should probably go to the end. Okay. I think that's it. And then 9 slice out 9 slice. You know what? Let's have this return a Boolean, because we can fail, right? The one failure case being if this guy is a null pointer. There's a huge problem of fragmentation because of languages, OSs, distros, programming paradigms. Yep, you're right about that. What's the solution? I'm betting on an x64 bare metal assembly, NASM style without macros. Yeah, I mean, problem is there is no clean solution, right? Like, even x64 isn't consistently used, right? Like, this thing right here is ARM. So even that doesn't work, right? In vec2i vec2iu. What did I call it? vec2iu. Did I really do that? It's supposed to be a T. So this is sort of the internal type, and then that's what I'm type defing it as, essentially. The I is for integer, right? So our actual vector2 is for floats, and then a vec2i is saying I want the integer version of that. I like how your keyboard sounds. Is it custom? No, it is not custom, but it is. It is the key. What is it? Keychron K2 wireless mechanical keyboard. So I actually have it hooked up in a cable right now because I'm charging it. But I like this keyboard a lot. It's a 65% keyboard, so it doesn't have the number pad on it, but it keeps it nice and compact, right? So I like it quite a lot. Not gonna lie, I think the future is ARM. It's too big of a bet, both for Apple and Microsoft. Yeah, I agree. I think ARM is definitely the future. It's way more power efficient for one thing. I think x64 is definitely going to be limited in the future. Yeah, we'll have to see. It'll be interesting to see where it goes. But yeah, I'm thinking ARM is going to be the way to go, right? It's already used in mobile so much already. Okay. So this guy is basically going to be minus the creation of this geometry. Well, even that, right? It's going to be a massive just math function essentially, right? So when we create this, we're also going to create the geometry as well. And then we'll probably go ahead and load all that stuff up, I'm thinking. Because when we create it from config, we'll have that as well. And yeah, so we do need a Boolean here returning, a Boolean return value. It's not going to work otherwise. Okay, so let's go to the system.c. And I'm going to put this one towards the top, I guess, for right now. I'm going to go to the bottom with that. Heck with that. All right. And we'll get rid of this. And the first thing we'll say is if we don't have that, we're going to return false, right? Straight out the gate. All right, if we do have it, we're basically going to copy all this crap over to it first before we do any sort of calculation. So we're going to say out 9 slice size equals size, out 9 slice atlas size equals atlas pixel size, out 9 slice let's do sampled min equals atlas pix min, out 9 slice sampled max equals atlas pixels max. And then we'll do out 9 slice corner size equals atlas. Nope, it's just corner size. Out 9 slice corner texture. Yeah, I need to standardize those variable names. They're kind of poopy. So that's going to be corner pixel size. And that should be everything we need. So let me split this. Go to this guy. So I'm going to rename these to be consistent with what we have here, actually, because I think that naming scheme works a lot better. So corner size is fine. It's like the only one that's fine. Corner texture size is going to be Pixel size, I'm thinking. Yep. And then size is fine. Sampled min is going to be Atlas pix min. Atlas pix max. And then Atlas size is going to be Atlas pix size. Okay, that makes more sense. All right. So the first thing that we need to do is thinking the easiest part to generate is probably going to be the corners. So let's see, where were we generating? We want to use both of these guys, I think. We basically are going to be using this repeatedly. Right. So I'm just going to paste this here for reference. Keychron is legit. They make good stuff. Yeah, they do. I'm really happy with this keyboard, actually. I like it a lot. I've gone through a lot of keyboards, like through Logitech and Corsair and stuff like that. This is by far the best keyboard I've got. Not the best at lubing switches and stuff. Yeah, I haven't really lubed these switches yet. It's on my list of things to do. I just haven't gotten around to it. The clean solution is to use the Intel syntax based on the Intel manuals. Yep. Yeah, AMD uses the same thing. Yep. We remove macros, transform preprocessor into an IDE feature. So the source files themselves are identical. Same with formatting and spacing. The preferences don't creep into the code. So I'm a little confused about that part. Because, like, I wouldn't necessarily want the preprocessor to be an IDE feature, I don't think, because I would think that would directly affect the way the code is generated depending on what IDE you compile with, right? Which would be potentially bad, I would think. Widgeler, hello. Welcome. How are you? You can transform the code into something that looks like C if you want, and there's an annotation to help you do that. Oh, so you're talking kind of like a transpiler then. I see what you mean. Okay. P. Gorley, welcome. First time chat. Welcome to the stream. Used to use a Keychron, but made my own builds now. Agreed, lubing switches is a pain, but during the right time with some jazz, it goes better. Yeah, I get that. Oh, I see what you mean. I see what you mean, Red. Okay. Yeah, I mean, I've thought about doing a custom build, but I don't know. This Keychron is pretty good, and I have no issues with it, so I have a hard time replacing it. Plus, I have a stack of keyboards over there that most of which don't have anything wrong with them. You ran out of patience by the time you got to your F-row switches. Nice. You're going to implement math in your compiler pretty soon. That sounds awesome. I'm doing pretty good, though. Thanks for asking. Yeah, we're finally getting into some UI stuff here, so that is awesome. Okay, so we generate 2D quad. This actually... I'm actually wondering... Now that I think on this, this function doesn't really belong here at all. This really is a geometry thing. Right? Like if we... So we could technically just call this a bunch of times under the hood. But I'm thinking we actually don't want all these to be separate geometries, right? So this isn't actually going to do 100% what we want. Right, because this creates a geometry config. But we don't really want to like have separate draw calls for each one of those things, which is what would result if we did it this way. So now that I'm thinking about this again, we should probably move this stuff. So this 9-slice create, I'm going to pick this up and move it over to move it over to geometry utils. And I guess we can say generate 9-slice. Right, and then over here, I can export that guy. And then instead of having an SUI 9-slice, let's move this guy too. And let's put this so we have geometry config. It's not really a math type, right? It's not really a math type. It's more of a... I guess we could put it in geometry utils H, right? Because it is a form of geometry that we're creating. So I guess we could put it up here. And let's call this instead. Let's just call it 9-slice. I think that makes a lot more sense. And we're going to forward declare geometry. Struct geometry. And what is this bleating about? Oh, just that. Okay, I think that makes a lot more sense. And so if we, first I'm going to rename this. All right. So we're not going to necessarily be able to use this directly. We are going to reuse a lot of this logic, I think. So let's instead grab this. And we'll do, I'm going to copy this or comment this stuff out and paste this here. And for this, so geometry config, out config. And we'll do a quick find and replace. Out config. And we're going to replace that with out config dot. And we'll run that again. Okay. As far as a name goes, I suppose it might help to have a name added to this as well. Let's actually let's get rid of this first off. We don't need that there. Let's do geometry utils h over here, and we'll add name to that equation. That way we can just use it. Right, and that can be any sort of generated name that we want. Oh, it replaced out config on all these. I did it on the whole file, didn't I? What a dangus. Well, it's only this function that's wrong, I guess. Okay, I'm just going to fix these ones manually so that I don't mess myself up again. Guess I could have just done it manually down below too, and I could have avoided all this. I don't know why that's bleating all of a sudden, but okay. All right. Catch up with chat. That's why you use a 65% keyboard, so you don't have as many keys to lube. That's hilarious. You're garbage at UIs in every possible way. Well, I mean, I've written a few of them over the years, so I like to think that I'm okay at it. So maybe you'll pick up something from here. Probably like what not to do in some cases too, like find and replacing code in your file for the whole file when you don't mean to. I'm going to have to write an essay to convince other people that my solution is the best, maybe a decision tree, then we debate on the assumptions and conclusions. I mean, go for it. I would read it. Do I have my nvin config anywhere? Are you using an existing thingy like nvchat or something? No. So I have my own config. Let me see if I can remember. I think it's that. Nope. All right. It is. Let me get you a link. Yeah, I will paste it here. It's not 100% up to date. I need to update it some because there are some things in here that have changed, but it's largely the same. So this is a description of how it's set up and what all of it is. And then there is a link in there to the actual, I think there's a link in here to the actual GitHub repo. I thought there was anyway. Yes, there is. So yeah, it's all there on that page. I started programming 3 years ago. Maybe the experience is relevant. I'm not sure. It might be. Okay, so we don't need this. I'm gonna get rid of this again. All right, so this whole section here, we are actually going to do repeatedly. So we have UI verts, and we're copying those into here. So I'm going to do this a little bit differently. Instead of doing this in a copy, we're just going to edit the array directly. And so if we think about the geometry that we're going to need, right, we can modify this to be what we need. So the vertex count is going to be 4 verts times the amount of slices we have, right? So that's just going to be 9. And that's going to be the vertex count, right? The index count is going to be 6 per quad, right? Times 9 quads. So we've got that. Right? And then I think the first thing that we should do is the corners. And so I'm trying to think of a way where we can sort of loop this and not have like a huge string of these things. So for each quad, we are going to have a string of these things, right? But I'm thinking maybe we just use position mins and maxes, and then texture mins and maxes. I mean, maybe put those things into an array and loop through the array. So let me think about this. How do we want to... So let's do the corners first. So we have 4 U32 I equals 0, I is less than 4 plus plus I. Right? This could be U8. And for each one of these corners, we need essentially a set of 4 vectors. So I think I can use I wonder if it would be better to just do it in the naive way to make the code a little bit clearer. I'm going to try it this way first with arrays. Okay, so the array is going to be position min, position max, texture coordinate min, texture coordinate max. So we'll have what do I want to call this? I guess I could say we'll have vec2i, and we're going to have a 2-dimensional array, 4 vectors in both directions. And we're going to initialize that to see if I can remember how to actually do this. vec 2i. And then we'll have, let's see, the first one is going to be position min. So that's going to be 0, 0. And then position max, we're going to do the upper left corner, right? So we'll do upper left. Is going to be let's go with out 9 slice corner size dot x, out 9 slice corner size dot y. And then the texture chords, that's a vector 2i, are going to be I'm not even 100% sure I can actually do this the way that I'm wanting to do it. The texture chords are going to be 0.0f for the min. And we're going to have to calculate. Oh, wait, we can't use 0.0f. I'm going to type it that way just to see if I can actually do this or not. Right, and then I think, can I do this? I've not actually tried this with multi-dimensional arrays, so I'm not 100% sure that the syntax here is correct. Expected identifier. Can you not initialize them this way? I haven't actually tried this before. Let me see here. I've got some. LLVM is getting complicated, yeah, for sure. Automod would, yeah. I think Automod didn't like the S-bomb. I think. I don't know why it's so sensitive. I thought I told it to allow that, but Zaros, welcome. How are you? Welcome to the stream. Automod blocked the term crappy. Okay, that's fine. It shouldn't block it anymore, though. We don't need high-level languages, I agree. Although you could also argue that C is a high-level language, right? You know what? This is going to be really complicated to do it this way. I'm not going to do it this way. I'm going to do it the naive way. Because that's going to be really hard to read. So, let's go top left. So position, we're gonna modify, or we're gonna position this thing with a matrix. So technically we want to go 0 based on geometry positioning. So for this first one, 0.0 is fine. I am going to get rid of this though. And instead we're going to go out config vertices. And To make this a little easier to read, I guess, because we're going to have a bunch of vertex numbers here, I'm going to say U32. Actually, I'm going to say U8. Quad index. Quad index. Nah. You know what? I'm not even going to do that. I'm just going to stick with 0 for everything. Alright, so out config vertices 0. Okay. Alright, so we'll just swap all these. Okay, why is it bleating about this? Out config. What is it suggesting the fix is here? It's not a structure or a union. Vertices sub-0 position. Why can't it? Is it just tripping? We do want... Let's go ahead and get this. So let's say this here. And so this is going to be, if I remember correctly, texture size. Yeah, image width and image height. So this is going to be out 9 slice, atlas. I think it was atlas size, wasn't it? Atlas pixel size .x and atlas pixel size .y. And let's use the out 9 slice for that. And then we have the... We want to use the corner... The corner pixel size is going to be for the maximum of this. Let's generate EVs. Okay. I'm just trying to think about the best way to do this. So we have out 9 slice. We want to use the... the minimum here. So the atlas picks min .x out 9 slice atlas picks min.y, and that's going to give us the minimums for that. And then we're basically going to have the same thing for all of this. Except this is going to be the atlas picks min plus the corner size, the corner pixel size .x, and the atlas min y plus the out 9 slice corner pixel size dot y. And those are really long, so I'm going to have to, unfortunately, split them up, I think. You know what? I can actually do back to I. Let's go with Atlas. Nah, that just creates another variable. Never mind. I'll just do it this way. I'm indecisive tonight, apparently. So let's just do it this way. Means it's going to be a lot of lines, but there's not really a cleaner way of doing this. At least not at the moment, right? Because all of our variable names are kind of a little verbose. And when we start adding them together like this, the lines get kind of long, so. All right, so this will give us our UVs anyway. So we can say this is going to be the TX min, TY min, TX max, TY max. Right? So that'll fill in all of those for us. We'll change them here too. Okay. All right, so there's that. And then we also need to generate the positions, right? So F32, we'll say pause X min, pause Y min, pause X max, pause Y max. And these are basically going to be just based on the corner size, right? So these are the actual positions. So it's not going to be as complicated as what's going on here. So pause X min is just going to be equal to, in this case, 0.0f, right? And pause Y min is also going to be equal to 0.0f. Pause X max is going to be equal to out 9 slice corner size X. Pause Y max is going to be equal to out 9 slice corner size Y. Right? And then we could use those things here. So this is going to be pause X min. And this is going to be the same thing. And then we have pause Y min. And pause Y min. Right? And then where we have height and width, those are going to be our max values. So we have pause X max. Oh, wait a minute. Why are these reversed? That almost screwed me up big time. They're just backwards on that one. Weird. Okay. Pause X max. Right? So we'll replace width with pause X max, and then this with pause X, or pause Y max. I think I have that correct. Let me just double check here. Okay. So that's correct. Don't need that anymore. Okay. Oh, right. It doesn't like this because vertices is type void. So we have to cast all of these. So what I'm going to do instead of casting it, because that sucks, is I'm going to create a convenience pointer. So instead of this, right, we're using vertex 2Ds. So let's say vertex 2D verts equals outconfig dot vertices, right? And then all of this, we should be able to just say verts sub-0, right? Let's see, can I... Right. So we could just swap this out all the way down. And be much better off. Let's take this guy. Move him all the way up here. And we're going to actually have to do the same thing with indices, right? So that's a U32 array. U32 in, if I can type, out config indices. For you C++ guys, you're going to have to like do this, right? Because the C compiler will allow that, but not the C++ compiler. So, all right. I think that is, so all we need to do here is we're copying this over. Yeah, so we need indices 0 equals 2, right? I forget what the command is. I know there's a shortcut to do this, but it's only a few lines. So we have 1, 0, and then 3, 0, and 1. Okay. So that is basically, we have to just basically repeat this over and over again for each one. Let's see. Let me go back here because I feel like I'm a little bit behind on chat. Hey guys, welcome, first time chat. Welcome to the stream. I'm doing some Vulkan and C++ and porting some of it to C. Here to co-code. Awesome. Well, welcome to the stream. Glad to have you here. Let's see. Using Clang D. Yes, I am. Let's see. You guys are talking about compiler stuff? Okay. Possibly bad idea. I'd be tempted to replace the vertices field with a union of pointers to different vector types. I thought about that, but what I wanted to do was support the ability to pass any form of data in there, and I didn't want to restrict it to types only known by the engine, right? So like we have this known type, right? We have the vertex 3D, which has all these fields. We have the vertex 2D, which only has these, right? These are known types to the engine, but user code could potentially come up here and say, oh, I have a custom vertex type that maybe has some extra data, but also doesn't use normals or texture coordinates or something like that. And so I wanted to keep it generic enough to be able to take any type of data, right? So that's the reason that we have the vertex size, right? The vertex count and vertices as separate fields, so that we can, when we feed this through to the shaders, right, the C code doesn't care about it. It's completely configurable as far as the shader goes, right? It's open-ended that way. But I see where you're coming from. Like, that would add type safety for sure. But in this case, we don't want to restrict it to only known types. The blurb below says using VS Code. Is this NeoVim? Did I not update that? Yeah, so I'm using NeoVim as my editor. I switched to it several months ago. So that's what we're looking at here. I do still use VS Code as like my debugger when I'm going to run code, but yeah. I use this for editing these days. Heading off to bed. We'll see you later. Have a good one, Wildra. Okay. So, that's the first one. Now, it feels like there's obviously a better way to do this, right? So I feel like we could probably come in here and say U32 v index equals, actually we should declare something else first. So we'll say U32 quad index equals 0. And then U32 v index equals quad index times 4. And then we can come in here and say v index plus 0. Right? I think that makes sense. Right? And that way we can just sort of increment that as we go. These have to be recalculated for each one. These have to be recalculated for each one. But I suppose, like, if we were to do maybe all these calculations up ahead of time and shove all those things into an array, then reasonably we could loop through this part and not have to do that, right? So we can say here, so this is for vertices. We could say here, U32 I index is equal to quad index times 6, right? And so we can then say quad, I index plus 0. And again, that makes it a little bit more dynamic. Now, as far as this goes, the indices are actually going to have to change as well. So these are going to be 0 indexed, right? So I guess I'll think off of this one. So I think we can actually say... I think we can say the same thing, actually. I think we can actually literally say index plus here. Right, because if the first one is 0, this will place us at the first one, which will be index 0, right? If we're in the second quad, it'll place us at index 6. Wait. No. I need to use v-index here. Right, because this needs to be i-index, the index of the array, but this is the index of the vertex that we're setting. Right. Okay. So now we should theoretically be able to loop through this part without much trouble. And then all we need to do is extract these. So that makes sense. What is the music? So the music is from a game called Heartbound, which is under development by another game developer here on Twitch, who has generously allowed me to use his soundtrack. So this is the official soundtrack for the Heartbound game. You should definitely check out Pirate Software. I've put him there. Actually, let me do a shout out. I suck at typing tonight. So I will put Pirate Software here. Do a shout out to his channel. So Thor is another game developer here on Twitch. He's developing a game called Heartbound, which is a non-traditional RPG. And it's really a fantastic game so far. He's, I think, almost done with it. And I definitely encourage you guys to check out his game as well as his stream. Yeah, he's actually the leader of the Pirate Crew, which is the Twitch team that I'm on here. So I highly encourage you guys to check that out. He has allowed me to use the soundtrack here as sort of some background music to sort of liven up the stream a little bit. So you've seen Pirate. Okay, yeah. So this is from his game. Yep. And he allowed me to use it. So okay. It still says VS Code at the bottom. Okay, I'll have to change that. I wonder if I can. Yeah, I can't do it from here. I'll do it. I'll make a note to do that. Okay. Switched to Neo Vim a few weeks ago, and honestly, I can't even use VS Code anymore without the Vim plugin. It's so great. Yeah, I feel the same way. And actually, I tried to use the plugin for a bit, but there were things, at least at the time that I tried it, that were not quite working correctly, like writing files and reading files and stuff like that. At least at the time, I don't know if they fixed that yet, but like you couldn't use the W command to write a file, and that was really annoying to me. Because I've got so used to actually doing that. And I'm just like, why am I doing this? I should just be using NeoVim. Especially with like all the plugins for fuzzy finding and stuff like that. Like the only thing that I really use VS Code for anymore is as a debugger, right? But that's about it. Oh, W does work now? Okay. Yeah, I haven't tried it in forever, but why not VS as a debugger? Too bloated? Well, for one thing, I'm on Linux. But yes, it's far too bloated. So if I'm running on Windows or something like that, I could do that, I suppose. But yeah, it's just really heavy. I'm not a fan. Tried setting up the DApp for NeoVim and it was painful. So I actually have that set up as well here. It just, I don't know. I've not been able to get into the hang of using it. I actually do have it working, but it gets really weird around like exception handling and crashes and things like that. Like it's odd. Used Doom Emacs for one day and got so used to Emacs Evo mode I haven't been able to go back to NVim. Yeah, I've thought about trying it, but I don't know. I got used to Vim because I also SSH into my work machine and use Vim that way as well, which doesn't work quite as well through Emacs, right? Because it's a GUI application. I mean, you can do it, yes, but it's not the same thing. Need to stop OS hopping. It's making me forget what software is. Yeah, I hear you. Yeah, I distro hopped a lot, but finally landed on Arch, and I've been here and been happy for quite a while. On Windows, VS is the only option, to be honest. Setting up a debugger for VS Code on Windows is a pain. It really isn't. Literally all you have to do is install one extension, which is this guy, the C++ extension. Like, it's literally like you grab it from the store, install it, and it works right out of the box. And if you're looking for a config, in terms of like how I have the launch settings set up and stuff, you can get this right off the repo if you want something specific. But I've got it working here cross-platform for Windows, Linux, and Mac, and it works flawlessly. You're currently using Arch, Windows, and OS X. Yep. Yeah, that's the three I had. I had to, unfortunately, boot into Windows last night to fix a couple things on the audio branch that I've been working on, because I needed to make that run under Windows too. And of course, that was a pain. But yeah, that's basically the only time I boot into Windows anymore, is when I have to like do something Windows specific for this. Sully the Cat, thank you for the follow. I appreciate it. Use Terminal Emacs. You only learned that there was a GUI a couple of days ago. Oh, interesting. Okay. You're probably the first person I've heard that actually uses Terminal Emacs. I play Rocket League too much, so I ended up in Windows a lot, but all of my programming is either on Arch or on my MacBook. Yep. Yeah, I get that. Although Lutris has come a really long way in terms of gaming on Linux. But yeah, I do get that, though. I get the sentiment for sure. Okay. So, I think the thing about these is I think I'm basically going to create an array that has these things and these things for our quads, right? And we'll just sort of configure these individually so it's very easy to understand. And then all we'll have to do is loop through these. And then I'll make this a lot cleaner, I think. So let's do that. Now I suppose I could have a multi-dimensional array. But I feel like a structure would be a little bit cleaner to look at. So I'm going to make a internal only structure. Struct 9 slice position text coordinate, right? Slice position text coordinate. And I'm literally going to take these guys, slam them in here. And then come here and say 9 slice position text coordinate array of 4. And I'm just going to zero the entire thing out, right? Actually, I guess I don't even really have to do that, right? I could just do this. And then here, oh, I need an identifier. That might help. Let's call this PT, right? Keep it nice and short. So we'll say PT index 0 TX min. We'll just do this and that. And then should be able to do the same thing here. Right? And so this is going to be top left. And in fact, let me scope this just to make it a little bit easier to understand what the heck's going on here. All right. So I'm going to take this. You know what? I'm actually going to make this a little bit easier to even use. So PT, oops, U30, U8, PT index equals 0. And PT index and now I don't even have to worry about copy pasta errors with this, right? All I have to do is change it here. So we'll do another one here, and we'll do top right. And this one is going to have PT index plus plus, right? So the top right one is going to need to be the Atlas let's see, Atlas pixel size. That's got to be the same for the pixel size. This is going to have to be the Atlas pixel max on the X, but min on the Y. I might have this upside down. I hope I don't. So that's going to be the max. We have to do max minus, actually. So max X minus out 9 slice corner pixel size dot X. right? Because we need to start at the right and move in. Y is going to be the same. And then for the max, we actually have Atlas pix max X only. Right? And that's already all the way to the right. And then the Y should be the same. The position min should be let's see, what do we call that? We have the corner, so it's going to be size minus corner size. Right? So size.x minus corner size.x. And the min will still be the same. The max will be the, let me think about this for a second, size.x. Right, that'll be all the way to the right. Okay, that makes sense. Let's see. Boy, I'm behind on chat. Okay. It works for me on Linux and Mac OS, but on Windows it's just a pain to maintain C++ projects without Visual Studio, at least in my experience. So the system that I've come up with is actually pretty straightforward, right? I use the same Clang configuration for everything, the same make files for everything, and I just follow a structure, and it works for me. And it's very easy to maintain. I find the Visual Studio way of doing things to be cumbersome, and not at all like anything else out there, which is really annoying. And so by using Clang across the board, it allows me to have a similar shared configuration across the board. And I can change the few minor things that I need in the makefile, right? You've been on Nix, OS X, and Windows. Yeah, I've not tried Nix yet. You don't even try to target Windows? I mean, it depends on what you're writing, right? Like if you're writing a game and you're not targeting Windows, that's a lot of your audience left on the table, right? Sadly, Rocket League has completely killed support for Linux and Mac because of Epic Games. Yeah, but I'll bet there's a way to run it on like DXVK. Right? If they use DirectX as a back end, DXVK is probably going to be how you run that. You used to use Arch, but you needed to distro hop again. What makes you want to distro hop? Good question. For me, it was just trying to find something that was easy and productive to work on. You're in love with your current Arch setup, so you're probably going to stick with it for a while. I feel the same about mine. You're using Awesome WM. I tried, instead of Awesome, I used Hyperland for a while, which is Wayland based. But I was running into too many issues trying to run things like Blender, and the tiling window system was kind of annoying when tried to debug software with multiple windows. So I kind of switched away from it. Let's see. Main complaint about VC is that the flags are different than everything else. Yep, that too. That's really annoying. But the nice thing about Clang is that it actually makes a lot of those translations under the hood for you, which is pretty sweet. Thought about Hyperland, but ended up staying on X. Yeah, I mean, Hyperland is pretty sweet, though. If more stuff supported Wayland natively, I would use it for sure, because I really, really like it. But yeah, I just ran into too many problems that were actually Wayland. It wasn't really Hyperland itself, it was Wayland. Danny Fritz, thank you for the follow. Appreciate it. X is great. Yeah, I mean, my biggest issue with X is the high DPI mixing, right? Like I have monitors that are high DPI and then monitors that aren't high DPI, and mixing those are really awkward. We have ads. All right, and we are back. So I'm just filling out the bottom right here. So it's mostly the same as what we've done already. So size dot y minus corner size dot y for the minimum, and then the max is just going to be size dot y. Right. Let me see if I've done this right. So we want the max x minus the corner size x, the max y minus the corner size y, and then we want the max x and the max y. Okay, so that's for the texture coordinates. And then the positions is going to be size x minus corner size x, right, for the min. Size y minus corner size y, and then size x and size y. So that's for the bottom right corner. And then the bottom left is going to be basically a mixture of top left and bottom right. So let's just paste this. We'll say bottom left. And we'll do pt index plus plus again. And so we have, we want to keep the x value, but we want to take the y value from this guy. So we can just copy pasta that. And the same thing here, we want to take the y value from here, but keep the x. And that should give us what we need. Okay. And, oh, yeah, same thing for this. Right? Cool. Okay. So we have our PT structure filled out. And so now we can actually generate this stuff. Right, and theoretically, we could actually generate everything except for the all 9 slices based off of this, actually, because the code's going to be the same. You know what? That's actually what I'm going to do for this loop. So I'm going to say for u32, I equals 0, I is less than 9, plus plus I. Right, and we'll go here, right? Because that code is not going to change. And so all we need to do now is just say pt and then sub I dot. And that's going to give us everything we need all the way down. So all we have to do is finish filling out that array, actually. Right? Okay. So indices is actually going to work perfectly fine by itself, right? So we don't need the PT structure for that. Generate the 9 quads. Right? So that means we actually, let's go ahead and expand this to 9, right? I was going to do them separately, but let's see. So we'll say corners first here. And then we'll generate the other sections based off of this. So I'm going to do the top center first. So let's grab this. So this is going to be the top center. And what we're essentially going to want to do is take the max from the top left and plug that in as the X for the min here. So the top left here is going to be this guy. And so we're going to want to use that here as the min, right? So it's going to be min.x plus size, pixel size.x, right? Wayland isn't going to save dead-end Linux architecture. Yeah. Linux's strong suit is also its weakness, right? Like, the fact that it's so flexible is also its weakness, I would say. That's part of what makes it so hard to support. Okay, so the center here is that. The Y should be fine. And then for the max of this, we actually want the min. We want the min of the top right, which is going to be this guy. So we want the min right, so here, right, right, so that would be the max x minus, right, okay. So that makes sense. So the position min and the position y are actually going to wind up being the same thing. So the position x is going to be the max x of top left. So we want this guy. So that's going to be You know what? I think I actually screwed some of this up. So I'm going to have to fix a piece in there. This needs to be min, right? The value needs to be that, but I don't want to change this as well. So, no, this is fine. This is data only. This is the only one that I had messed up. Okay. So the min is going to be the corner size X, which makes sense because it's 0 based. And then the max is going to be basically the out 9 slice size minus the corner size X. Oh, size X. That looks right. Okay. So top center, I'm going to do bottom center next because that's very similar to this one. All we have to change is the Y, right? So the X's on these remain the same. The Y, so the Y in this case is going to be, the min Y is going to be Atlas pix min Y plus out 9 slice corner pix size Y. Right? So that's move it down from the corner. So that should be fine. Okay. And then, oh, did we, that would have been a nasty bug. Need to increase this counter. And then for this one, this actually needs to be the max of Y minus the corner pixel size. That'll give us that. The position Y minimum is going to be out 9 slice corner size dot Y. Right? Again, zero based. And then the max here is going to be out 9 slice size Y minus corner size. And that's going to be the bottom center. Okay. Let's see. Yeah. All the stuff you guys are saying about Linux is basically true. Yep. Like, don't get me wrong, I love Linux, but it definitely has its problems. I like it a lot better than Windows, though. That's for sure. All right, so let's do left center, or say left middle is what we'll call it. And I'm going to base that off of the top left as well. All right, so we'll go down here and we'll say middle left. So this is going to be min X, which is correct. And then the Y needs to be plus out 9 slice corner pixel size dot Y. Right? So you need to move that down from the top The image coordinates is going to be max on the y-axis. And then we actually have to subtract the corner size. And then positions, the left is, the x is still going to be 0. The y is going to be out 9 slice, corner size, y, right? So it's going to be that from the top. The max is going to be corner size y, but we need size.y minus that, right? So overall size minus that. I think that's all correct. Yep, okay. So we have that. We need our incrementer. And then we'll need the middle right. And this is basically going to be, so the min is going to be plus, wait a minute. Now the min x on this is going to be max x minus out 9 slice corner pixel size y, right? So that's the inside edge, and then this will be the outside edge, which will just be atlas pixel size y. Wait a minute, did I just do... Should be x that I'm modifying, not x. Right, okay. So this is not going to subtract the corner size. Right, okay, that looks good. And then the posx min is going to be out 9 slice size minus out 9 slice corner size x. Oh, I forgot the x here again. Okay, so we got size x, we move that in. The posx max is going to be out 9 slice size dot x. Okay. All right, so that's 8 of the 9 done. And finally, we have the centerpiece. So center. So the center is going to be basically the corner size in all the way around is essentially what that's going to be. So we have the minimum for this is going to be the pixel minimum x plus, oh wait a minute, this has the y on that, which means this one does too. That was almost a nasty bug. Did I do that anywhere else? No, okay. So we move this in from the minimum by the corner size. The y is moved in by the corner size. And then for the max, we want the max of the x minus out 9 slice corner pixel size dot y, dot x rather. And then y is the same thing, right? So that's our texture coordinates. Okay, so our position x minimum is just going to be size corner size x, corner size y. And then our maxes are going to be the size minus the out 9 slice corner size dot x. Right, and I've actually used the wrong one here. This should be out 9 slice. Right. Looks like I've done that a few times, actually. Okay. All right, so I think I've got all those right. So basically what we do is we fill out one of these for each of these quads, right? And then our texture coordinates and our positions should all kind of account for this. And then we loop through, we generate all of our verts and indices. And then, let's see, out config. That's our geometry config. And then actually the only thing left that we should have to do, is this bit. So we can go paste that here. And let's see, out 9 slice. Out 9 slice. Oh, it's not out 9 slice, is it? How config? Oh yeah. What did we do here? Geometry. So actually, this is just going to be... We actually don't need this anymore. It's just going to be G, right? Pharmacy Brain, thank you so much for the follow. Appreciate it. Oops, looks like Automod caught a couple things here. I'm just going to call you Sis. Thank you so much for the follow, because I'm not sure how to pronounce that. So thank you for the follow. I appreciate it, and welcome. So we are currently implementing a 9 slice. And we're doing it this way so that we can basically have this function that generates that for us. And we don't have to think about how the geometry under the hood is generated. We can just generate it this way, right? Okay, so... that is that. So this can literally just be G. We acquire that from the config. Acquire from config. That uploads it to the GPU. And we should be good at that point. We do probably need to clean up the config, though. Because I don't completely recall. Acquire from config. I don't think this keeps a copy of the config. No, it doesn't. Okay. So we actually need to, we're creating some stuff up here we need to actually get rid of. So I'm actually, just for reference, going to copy all this stuff. And paste it down here. And free it here. And do the same thing. And delete these, delete those. Okay. So that way we don't leak that memory. And this should technically do everything we need it to. All right. So the next thing we need to do is actually plug this in to the control, which we actually haven't created yet. But then we should be able to render it fairly easily. So let's go back to UI system. So literally all we need to do is just one of these. And we're going to call this button control. So oops. All right. Everything else should be the same. So paste the definitions of these down here. And fill these guys out. Which actually I'm probably going to be able to copy a lot of this straight from this guy. So I guess I'll just work my way up, right? I'll start at the render. So all this stuff is the same. Oh, we don't have SUI panel internal data. We do need to create a structure for that. So let's do... We're obviously going to have a lot more to the button besides just this rendering stuff, but... rectangle. I guess that's going to be... We'll call that size, right? Instead of holding geometry itself, we're going to hold 9 slice. I guess I'll call it that. The other things we'll need. Color, I guess we'll need too. Alright. So, SUI internal data. button internal data. This is going to be if type data end slice geometry. Change this to end slice geometry. Right, and everything else should be the same. Cool. All right. So that's render. Update, I don't think... Well, that is going to have stuff, but for right now, we'll just scaffold this in here as such. Unload. Oh, we don't actually have any unload here. We're going to have to fix that too. All right, so let's just do load. Right, and I'm only copying this stuff because it kind of gives me a basis to work from. Like, it's not all going to be the same exact stuff. Okay. So this is going to be... button internal data. We don't need to do any of this stuff. Instead, we need to do generate line slice. The name of it is going to be I'll do self.name for now, I guess. So the size is going to be type data size. Sam, thank you so much for the follow. I appreciate it. Welcome. Type data size. The Atlas pixel size. So that's going to be the texture that we load. Do we have... That's just going to be the typed state. So we need to actually get that. Typed state. UI Atlas. Texture. Width. Oh, it needs that as a... Oh, it needs that as a vector2i. Vector2i. Atlas size equals. Right, it's going to be this. Right, and then this is going to be Atlas size. Fernando, thank you for the follow. I appreciate it. Welcome. All right. So Atlas pixels minimum. So that we actually have to figure out. So the area of the 9 slice is basically going to be this. So our minimum is going to be 151.12. So we'll put that. So back to I 151.12. Now, obviously, I'm hard coding this stuff for right now. We're going to take that into we're going to take that in as configuration when we create it here, right? So we have the atlas min, vec2i, atlas max, which is going to be the maximum, just looking up here, is going to be 159.20. Oops. 159.20. Right. So atlas min, atlas max, corner pixel size. Let's see, what did we say that was going to be? 3 by 3. So vec2i, corner pix size is going to be vec2i 3 and 3. Oops. Right, corner pixel size, vec2i corner size. So vec2i corner size 2i. And we're actually going to want this to be kind of big on screen. So I'm going to say 10 and 10. All right, so we'll say corner size. And then the out 9 slice. So we want the address of type data end slice. And then we want to check this whole thing for failure. And if it fails, failed to generate 9 slice. And return false. Type data.size. Oh, that's probably because it doesn't want it as a floating point. Did I do a... Oh, right. Why is size a vector 4? This should be a vec2i. Okay. All right, that should give us what we need. Oh, I already had this here. Get rid of that. So we got the texture map, we get the shader resources and all that stuff, so that all should be fine. And that should be a load success. So we do have some hard-coded stuff here. Hack. To do, remove hard-coded stuff. Let's see. Let me see. Maybe the fragmentation is necessary because it allows people to have more freedom to choose what the computer should do. Projects die if they aren't useful. Maybe it's okay. The alternative is something that does everything at once. It's probably going to be bloated. What's the context behind that? You talking about the fragmentation of, like, doing it this way? Okay. That seems fine. Destroy. We're just going to call the base method. So we've got that. And then the create, we actually need to set up all the function pointers, right? So we will do this. Right. And we got ads. So we got about 30 seconds left on ads. All right, and we're back. Let's see if we can wrap this up here. We're not going to get to the input tonight, unfortunately, but if we can at least get this to render, I think that would be a definite step in the right direction. So our create is basically just setting up a default size, which right now is just a reasonable default, right? We eventually do want to have that be configurable, but for right now, this is what I'm going to roll with. This should be enough for us to actually be able to render it, I believe. So let's go to testbed main and so here's where we create the panel. And obviously we need to come up with a better way of doing this, right? We need to come up with some utility functions that handle this kind of stuff for us. When our actual standard UI should handle this for us. We're kind of just sort of forcing in line like all this stuff to be loaded and stuff up front. Obviously that's not what we'd want to do when we change like game screens and stuff like that. We would want to do this kind of stuff on the fly. We're just kind of testing it right now. So I'm going to copy this whole section. And we are going to create a button. Let's see. So I'm going to call this, oops, test button. Go figure. Failed to create test button. Failed to load test button. Get the states. Register the control. This is something we need to do. Need to actually create a test button. So this is going to be test button. Test button. Test button. going to do the same thing here. Same thing there. Add child. Test. Test button. Set the test button active. Test button. Okay. So I think that's going to work. Let's try building and see if I missed anything. Built successfully. All right, let's run and see where we wind up. So let's see, did we get any... I don't think we got any errors. So the question is, where the heck is the button? Well, you know what? I suppose I could add it as a child of the panel, actually. Right. Let's try that again. So I'm not seeing it actually create. So the question is, why? Let's debug. I'm going to put a breakpoint here. Okay, so we create the internal data, set the size. We set all of the function pointers, take a copy of the name, so that's good. So we load. There's the problem, the atlas size. So it would appear that texture isn't loaded yet. It is not. Okay, so what I'm going to do is, for now, I'm just going to hard code this, right? Just so we can actually see it working. Because otherwise it's all going to be incorrect, right? So we'll need to actually handle this. In a normal situation where we're not like forcing all this stuff to be loaded ahead of time, this texture would have been long since loaded. So let's try that again. Let's see, that's the... Where did my debugger, like, stop? There it goes, okay. So we know the create works. Right, so that is good. We can actually move this breakpoint to down here. Right, generate 9 slice, so that seemed to work. Let's take a look at the data on that, though. So literally should be, okay. 10 slice. All right. So corner size is 10 by 10. Corner pixel size is 3. Okay. The size is 200 by 50. 151 by 12 is the min. Max is 159 by 20. And the Atlas pixel size is 512 by 512. So I think all of that is good. The geometry has an ID, generation. Yeah, we didn't generate extents for it. That's fine. Okay. Has vertex and index data. Whether that's correct or not, we'll see. Okay. Shader resources. So that should be good. Register the control. So that should be fine as well. Right, so we set as an inactive. Add the child. Let's make sure that is working correct, because we haven't actually done that yet. So the parent does not have that, so we'll create an array. The child does not have a parent, so we don't need to do that. We don't need to move it. Parent children, we push that into there. Transform set. Okay. And then update active. And we should be good. So let's see where this lines up now. Ah, okay. We are drawing it. It's a little hard to see though. We might need to expand that some because I'm not 100% sure it's actually pulling those. I'm not sure it's pulling those pixels correctly. I don't know if I told you, but I'm going to be making an OS that records non-determinism to build a database of register values for old frames on demand. So you don't need to single step. You can see frame context in the spreadsheet, etc. There's a tool that can do something like that for Linux, but it's too slow and you can't edit and replay. That'd be super interesting if you could actually make that fast. All right. So it doesn't look to me like our geometry data is generating correctly. It looks like the only thing that's actually correct is our center section here. So I think what I'm going to do is crank up the old render doc and see what we are actually getting. So let's launch this and capture a frame. We'll say that one, right? It doesn't really matter, I guess. Quit this. And let's have a look at it's not going to be that one. It's probably going to be this one. Yeah, this is the last thing to be drawn. So interestingly, I'm only seeing two triangles here. In position 10. Oh, wait a minute. That would be why. Looks like our indexing logic is wrong. Yeah, it's just using the 0th index all the way down, so it's correct up to here. And then it's just wrong. Okay, well, that would certainly do it. All right, so let me go to generate 9-slice. So v index quad index times 4. So we have I index. So I think these are correct. It's these that are wrong. So v index is quad index. Oh wait, are we actually... Oh, what a dongus. So I have this quad index that I'm never incrementing, right? Which I don't even actually need. So instead of using quad index, it should just be I, right? I is the quad index. All right. Let's try that. Hopefully without any stupid errors this time. Okay, that's better. So it looks like some of our calculations are off, but it looks like a lot of them are actually correct. So we can see here that we have a top and a side. Like, the calculations are a little bit different here. The left looks bigger than the right, which is interesting. Looks like the left has scaled up and the right has not. And then the bottom is just completely missing. So let's have a look at RenderDoc again and see what it is giving us. So I don't want to save that. No. And I'm just going to use this one. I don't know why I never like using the first frame unless I'm testing something on startup, which I suppose I could check out, but all right, so let's take a look at the mesh viewer. So I'm thinking this might be a oh, interesting. So we got 3 corners. 2 of our sides are overlapping, I think. Or one of our corners is just wrong and overlapping here. So let me see. So this is the first one, the second one, and the third one look correct. So it's the fourth one that's wrong. Okay. So that's going to be top left, top right, bottom left. So let's take a look at this. So bottom left, the minimum for that should be the Atlas pixel minimum. The maximum for X should be the minimum X plus the pixel size X, corner size X. Okay, I think X is correct. Y, the minimum for that is going to be the max Y minus the corner size Y. That makes sense. And then Atlas pixel size. Okay, so I think the texture coordinates are correct. So this is the bottom left. So left, it should be 0. The right size of that should be corner size X. Okay, that's correct. So the minimum on the size, or the position rather, that's bottom left, right? So that's size Y minus corner size Y. So that also seems correct. But then the maximum is just the corner size Y. That doesn't seem right. I'm thinking the maximum should be size Y. Which also means that probably everything along the bottom is wrong. Because they should all be size Y along the bottom, I think. So bottom center should be size Y. You know what? Let me test this first and see. Let me see that corner is fixed first, and then I'll fix the other ones. So we'll get rid of that. Launch, don't save. Okay. I think that might have fixed it. At least for that corner. Yep. Okay. So the top is fixed. Wait, that was the center? Why is the center next? Center should be last. And then center again. So, wait a minute. Let me think about this for a second. So we have top. Top center. Bottom center is what's wrong. Okay. So the bottom center Y's are what's going to be wrong there. So the minimum for the bottom should be definitely not this. It should be max Y minus size Y. And then this should just be max Y. All right. Let me run it here. No, it's still not right. Okay, let's have a look at our data. I'm gonna have to wrap this up in a second, guys, because I have to go. So top, bottom is still wrong. Okay. Well, that is where I'm going to draw the line for tonight, guys. It's late, and I have work in the morning, so I need to go. But let me check. I think for tonight, first off, before I close out, thank you guys for actively participating. I appreciate it. Yeah, so close but so far. Yeah, we need to do input and stuff like that too, so we're really close. Probably what I'll do is I'll wind up fixing this offline and just show you guys a diff so we don't waste too much time doing this on the next stream. But yeah, in fact, git add work in progress buttons. I'm going to push this now so you guys have access to it. And then my diff can be showed separately when I figure it out. But yeah, I'm going to go ahead and drop my socials in chat so that you guys can follow me in all the places and all the things. And tonight I'm going to raid Ferret Software because it's a really good cause. It's a ferret rescue. For ferrets that have been used in like medical testing and other not so great situations. And it's run by Pirate Software, and he basically takes all the ad revenue and all the revenue from that channel and gives the ferrets a good life, pays for their medical bills, their food, all that stuff, which is really expensive. And I think it's a really good cause, and so I'm going to raid that channel. And thank you guys so much for following along and joining, and I will see you guys on the next stream. So see ya.